Today I'm here to talk about why we built a private cloud platform for Kafka and how we built it. I'm Avinash. I'm a senior consultant at Platformatory, and we've built a product called Streamtime, which is what I'm going to talk about. I'll try to keep this quick. Maybe in the next 10-15 minutes I'll run through this. But first, let's talk about why did we build this. There's already existing managed services for Kafka on the cloud, the likes of Confluent and MSK and the others. So why did we build something for private cloud deployments for Kafka? The reason is, if you notice, a lot of these cloud deployments for Kafka are slightly expensive when you compare them with maybe deploying yourselves. There's of course pros and cons for both approaches, but the numbers suggest that they're slightly expensive. They might not be for everybody. There's a couple of blog posts that are linked to this. So once maybe we share the slides, you can probably go through them. They're by Stanislav on. They've talked about the numbers as to why it is expensive on the cloud. But there are ways you can optimize for this as well, but they're not as straightforward. And a lot of these involve going through the enterprise sales, which I'm sure most of us developers don't want to deal with. And there's a new kid on the block, which is BYOC. A lot of vendors are now supporting bring your own cloud, which is the cloud provider manages the control plane, but the data still remains on your own cloud account. You can bring your own cloud account. But there are still challenges with this. This has the same problem with the enterprise sales. But the primary challenge is also this is not air gappable. That is, you cannot run it on air gapped environments. You still need to run it on the cloud, and you still need to have connectivity to the cloud provider's management plane. So that's another reason. And finally, there's a lot of new Kafka vendors that are coming up. So there's a lot of new flavors of Kafka that are coming every day. The likes of WebStream, or there's innovation in the Kafka space that is happening regularly. So the Kafka that you might have deployed today might work well, but as you scale up, it might not work out really well for you, or you might want to migrate certain workloads to maybe back to open source, or any certain vendor that works well for that specific use case. For example, the diskless Kafka, that's the new thing where you run everything on S3 as a storage. That might work really well for maybe observability workloads where latency is not of concern. So you might want to run Kafka on different flavors of Kafka for different use cases, or maybe migrate along the way. So that does not really work when you're on a managed cloud provider. So all of this point to deploying Kafka yourself, that is self-hosting Kafka. But I'm sure if there are any Kafka operators here in the house, they all know that is not simply not easy as done as said. So there are multiple things that you'll need to keep in mind, and a lot of this is professional services niche. So that is what we do every day at Platformatory. This is what we do, but we want to solve for that. That is, we want to make this easier. If you want to deploy Kafka, there's a lot of Java and JDK configuration that you need to understand, and also just getting the security right with the certificates. How do you generate certificates? How do you rotate them? How do you ensure that you have various client listeners talking using the right certificates? And same with the security as well. There's multiple forms of security that Kafka offers. Which one do you choose? How do you configure them? How do you add new users? How do you roll credentials? All of this is still a concern. And plus, if you have to deploy this on top of maybe Kubernetes, then how do you expose your listeners? How do you get the networking model right? Do you do host-based listening, port-based forwarding? Do you put a load balancer in between? So I'm sure anybody who's run Kafka here understands that putting a load balancer in between Kafka is not straightforward, not done. And you just don't run Kafka for the sake of Kafka. So you would want other components as well. You would want to get data in. How do you get data in with Kafka Connect, and maybe do some stream processing with maybe Flink or KSQL, any of these stream processing engines? You would want to deploy that as well. And of course, this is not, and this also requires certain engineering effort, and also you'll need Schema Registry to ensure you have schemas. And finally, once the deployment is done, you'll also need to plan for the disaster recovery, because you're managing it yourself. This is not a managed service. So how do you plan for a DR? How do you do a failover? How do you design playbooks for all of that? That is still of concern. So that's what we want to solve for with this. The primary design goal for building this is you come with your own cloud account or your own data center or any place that you can run Kafka. We have standardized on the interface with Kubernetes, but essentially you bring your own cloud account and run it on your own cloud account entirely. And the goal is to be able to run any flavor of Kafka. So it is not just try to one vendor or one flavor of Kafka, not just open source or not just Confluent or any flavor of Kafka. You should be able to run it with any flavor of Kafka on just about any infrastructure that supports Kubernetes. The goal is to be able to run this within 5 minutes. That is, you don't have to spend weeks trying to get a Kafka cluster up. Rather, you should be able to get this within minutes and not just get any Kafka cluster, a production grade cluster that is something that you can run a significant throughput with and have the right security profiles. Final goal is to make it make the ops boring. That is when you have to deal with a fire with any Kafka incidents, you shouldn't have to pull your hair and try to struggle too much. That is the goal. The primary USP is there are certain standards that we've adopted. Of course, this might not work for everybody, but these are standards that we've seen work well. Something certain good opinions that we feel work well, and you don't have to figure out what configuration do you need, what do you not need, and try to figure out all the Kafka properties and the other component properties. And you should be able to self-host it and operate it yourself. Just operate Kafka like you would do it on a cloud environment. So if you create a Kafka cluster in any cloud environment, it is just clicking a couple of buttons and then you get a cluster ready. That is the goal here, where you have a UI with a self-service interface without you having to worry about any Kafka internals for just getting a Kafka cluster running. All of this requires a management plane, which is what we built. What the management plane does essentially is just provides an interface for deploying on any infrastructure. So when we say infrastructure here, we're primarily talking about Kubernetes, and provide a model for multi-tenancy. So there's different ways you can define multi-tenancy. That is, you run multiple Kafka clusters on the same infrastructure, or run multiple infrastructures within the same organization. So there's multiple ways of defining multi-tenancy, and this management plane should solve for all of that. And just the management of the Kafka clusters that you deploy and fleets of the infrastructure, it should solve for that as well. And since this is completely deployed on a self-managed environment, you would want to bring your own identity, your own OAuth provider, or your own users that should be able to log into Kafka, both human users and client, uh, the computer users. And they should have enough observability, because not just deploying Kafka, it should also provide for you to be able to look at what's happening in your Kafka cluster. There's also the new AI ops with you should be able to get answers for anything that is happening on your Kafka cluster with AI. We'll talk a little bit more about how we can achieve that, and just audit logs of what's happening in your environment. And finally, you'll have multiple teams using Kafka within an organization. You would want to pinpoint how much does each Kafka cluster cost the organization. How do you do chargebacks to the various teams, and just get a real sense of how much is your Kafka cluster costing, based on the actual usage or based on just the cost. At a quick overview, this is how the architecture looks like. There's two primary components here. So there's the management plane, which is on the left, and the actual workload cluster, which is where Kafka runs. The management plane exposes a UI where you can configure or create your Kafka clusters, and that talks to an API, which at the core of it is the durable execution engine. I'll talk more about how we built it and the challenges, etc. But the durable execution engine is CI/CD like engine, which ensures that it orchestrates the various steps involved in getting a Kafka cluster up and running. So this is based on our experience deploying Kafka clusters. We've sort of written that down as code and ensured that it works repeatedly. And there's other components like the cluster manager, which is responsible for getting a Kafka cluster up and running. And primarily the other components are the health agent, which is what is responsible for answering any questions that you might have about your Kafka cluster, about the health of the cluster, and just be a co-pilot in troubleshooting. And the billing manager, which takes care of ensuring that it regularly accounts for the cost by the Kafka cluster and stores that in the reporting, which you can then use for chargeback. And on the other side, there's the actual workload cluster, which is where the Kafka clusters are deployed. So this can be any SKU that you can deploy. It can either be Confluence, Trimzy, or any. We support a lot of other workloads where you can just select which workload you want, and you should be able to fit that into the right workload cluster that you've created. And it should also be capable of doing the tenant management for how should it place the Kafka cluster on the actual Kubernetes cluster based on the workload, based on the load. So you define a policy on how do you want to distribute, where do you want to place your Kafka cluster. So this is primarily for organizations where you would have multiple clusters, and you want to get away with the headache of actually sizing them and placing them on the right infrastructure. And it should expose the right listeners for the clients with the right networking model, and have observability and monitoring built into it. So now I'll talk about the actual key challenges of building such a platform, and what goes in when you would want to actually build such a similar platform. So on day zero, this is what we were solving for, which is you should be able to bring your own cloud account, bring your own certificates, your own domain names, because this is all running on your own environment, and bring your own identity providers for the Kafka authentication, and for the UI authentication, and for SSO for Kafka UI, etc. Since Kafka supports SASL OAuth, this is something that this is one of the standards that we've opinionated on, because this works really well, where if you want to add a new client for any application, you just go create a client on your OAuth provider without having to touch Kafka at all. That way, you don't really have to tinker a lot with Kafka. And finally, bring your own LLM. So for troubleshooting, it's not we don't want to ship our own LLM. Rather, we have built an MCP server that is aware of whatever configuration that we've configured on stream time, and it can also talk to the monitoring metrics, and also the cluster itself, and try to answer whatever questions one might have about the cluster. So for that model, you would want to bring your own LLM as well, whichever provider that you currently use or you feel is more suitable for this. You can go ahead and plug that in. And finally, this also requires ensuring we have a bookkeeping for all of this, whatever that we create for the various components that we create. That is, we create our own certificates, we create the identity provider, the LLM configuration, the Kubernetes configuration, the cloud account configuration, and Kafka. All of this needs to be created and also scoped down to an organization. So when I say organization, that's the definition of a tenancy here. So you would have multiple organizations within an actual organization. So multiple teams within an organization. So you would want to scope them all based on that. And when you bring this up on your own environment, you should also have a way to bootstrap that root organization itself, the first organization that's created. So this we typically do that with some configuration, that when you start stream time, you can just configure the root organization, using which you can create multiple other teams or organizations. And one of the key things that is required is the role-based access control. So that is, there are multiple personas involved here. So there's, of course, the administrator persona, which can do everything, but there are other multiple personas on your organization. So there's a team that is responsible for just maintaining the infrastructure, maybe just getting Kubernetes up and running. So that's one persona. There's another team that is interested in getting a Kafka cluster. Just they should be able to click a couple of buttons without having to worry about Kubernetes. So that's another persona, and there are other personas that are involved. So each one should be able to do what they can do based on their access. And finally, you should be able to define policies for the various Kafka clusters that you create. That is, you would define a policy for how should the Kafka cluster look like. That is, what should it use for security, what should it use for the networking, what should it use for the tiered storage, etc. So the clusters that we create also come with tiered storage, so you can define where do you want to tier the data. So all of that is defined as a policy. And the final thing is everything should be interactive. You can just do everything with a UI. Um, Another key challenge is how do we make this work with M cross N combinations? That is, you have multiple cloud providers, you have multiple Kubernetes providers, and multiple Kafka providers. So how do you make this work with N cross N? That's primarily, that boils down to defining the policy with saying if I want a cluster with Confluent, then and on AWS, then I would want to set these as the configuration. So that is defined as a policy. And then yeah, and you would also define all the networking options that are available for the Kafka clusters based on the workload. So some providers might expose both external and internal listeners, some might not. So all of that needs to be accounted for, and ensuring that each tenant does not the data from one tenant does not move over to another. But the way this is solved is primarily we've built a Terraform execution sandbox on Temporal, which is our durable execution engine. So if anybody's run Terraform for creating any cloud infrastructure, there are challenges when you would want to automate that. That is, what happens if the execution stops in between and there's an inconsistent state. So we have had to solve for that, where we've built our own custom execution with Temporal, where you can execute Terraform like code and create infrastructure. And another key challenge is the ability to bring your own VPC or bring your own Kubernetes cluster, because typically if we were to create the Kubernetes cluster using this, you don't want to create a new VPC just for deploying Kafka. That way, then your teams will once again have to pair the VPC with wherever the actual client workloads are and have to deal with that. Instead, you should be able to bring your own VPC. So if a person brings their own VPC, we should have the right guardrails to ensure that VPC has enough IP addresses and it has the right configuration that we expect for deploying Kafka. So all of that needs to be accounted for. And same thing with bringing your own Kubernetes clusters as well. So once we have a Kubernetes cluster ready, then it all boils down to installing a few custom operators for the custom operators for deploying Kafka itself, and also for the other shared services or the services that you would require for just getting Kafka running, which is primarily the telemetry and our chargeback and the agent, etc. So all of that needs to be installed, and ensuring that the workload is running. And with challenges on day two, you would once you've deployed the cluster. So when comparing this with the managed cloud offering, the cloud provider takes care of ensuring that your Kafka cluster is up and running all the time. So if you were to go down this route, then you're self-hosting essentially. But all we've solved for so far is just the ability to deploy Kafka clusters quickly, so that your teams get clusters up and running. But there's still a chance that it can go down at any point, and you don't want to be waken up at 2 a.m. So this boils down to ensuring that a lot of this is, of course, possible now with AI. You can just ensure that you know what is happening within your cluster using the AI agent. And but there's a few guardrails that you can also ensure that this does not happen, which is allocating the right workload Kafka clusters to the right Kubernetes clusters, and ensuring there's right scaling policies, so that you scale based on the actual workload, and ensuring that there's relocations. That is, if a certain Kubernetes cluster is not healthy, you should have the ability to move a Kafka cluster from that to another healthy cluster. So all of that logic needs to be implemented, which is what we had to solve for. And I think this is just, yeah, I think that is a couple of slides which is just talking about some of customer engagements and some of the actual customer implementations and some testimonials. But I'll conclude at this. I don't want to stretch it beyond this. Are there any questions, anything? Yeah.
Where is the metadata of the Kafka cluster being managed, whether it's appropriate for clustering?
Do you mean the metadata of Kafka metadata or the actual cluster? Yeah, so that's primarily stored in this the backend which connects to a database. That's where when you create a cluster, everything about that cluster, the configuration, the security mechanism, the networking model, the tiered storage provider, and a few other things are all stored over there, which is of course what helps the AI agent as well to uh, answer the questions about the cluster.
That's your own solution, is it?
Yes.
And it's deployed in which cluster? It's your cluster, is it?
No, the whole thing can be deployed on any customer environment. So this whole the management plane is also on the customer environment, and so is the workload. So this is the primarily difference between a cloud BYOC versus what we're trying to build, where everything is on the customer environment. You don't have to worry about uh, anything data leaving your environment at all. Yep.
One quick question is how do you, or what strategies of auto scaling do you use or scaling do you use? Because Kafka 101 tutorial says that you have to plan your scaling in advance and define your brokers and partitions, and
Yes.
then eventually you can scale your consumers accordingly, right? So how is there any way that you are also able to scale your brokers and partitions?
Yes. So that kind of depends on the workload. For example, with Confluent, they have their way of what do you call this? Essentially, they have the automation where you can automatically distribute partitions as you add more brokers. Same thing with the open source. There's an open source implementation called uh, just can't seem to recall it, but we've added those so that as and when you add more brokers, the partition just get automatically distributed, so that you don't have to worry about moving partitions around. And so that's primarily the challenge with scaling Kafka brokers. So when you add a new broker, there's going to be hot partitions in certain brokers. So there are now tools that will allow you to actually move partitions around based on the workload as and when you add new brokers, etc. We rely on top of that to add more brokers. And the scaling strategy itself is based on the load. There are certain metrics that we look for, and based on that we have an HPA that automatically scales in certain cases, and certain cases a VPA based on the actual workload. Based on what we've seen works best for that workload, we've set the policies for the various workloads.
Do you have MCP servers exposed?
Yes. So the every stream time deployment comes with an MCP server that sits along with the management server. So that talks to the management server's database and also the actual workloads metrics. So it has all the context of what is happening on the cluster, and should be and can answer the questions about the cluster.
Going to reside in customer environment?
Yes. So the whole thing will be on customer environment. So the goal is you don't have to run anything on the cloud or on the vendor's cloud. Everything is on your own environment.
So it has to access the actual logs?
Yes. Yes. So it has access to the actual Kafka metrics and also the logs, based on which it will be able to answer questions, along with the metadata that we store in stream time.
So for Kubernetes scaling, we use Keda.
Right.
So imagine that we have some queue, or let's say SQS queue also, and how do we merge your ecosystem with Keda? And there are many other UIs and things available like Kera, Zookeeper, and like there are like Kaf.io, like different types of UIs. So how do you interface with these open source tools that comes along with it?
Yes, great question. So the first question was around the Keda. So Keda is primarily for scaling the consumers. So based on it's an event-based scaler. So based on the consumer lag, you would want to scale your consumers. So that does not really work well for brokers, because there's no such event that gets generated saying you should scale the broker. So for brokers, what we've seen work well is just plain old HPA. Now that you have the ability to move partitions around automatically, so HPA works really well for brokers from what we've seen. And with respect to the UI, so it once again depends on the workload. For example, Confluent comes with Control Center, which is what we support with SSO, and the other providers, other enterprise providers, have their own UI that we support. And for open source, we don't really support an UI. And what we support for an UI is just the management plane, not the actual Kafka UI. That is, you won't be able to actually go create topics or do any of the other activity you do on a Kafka UI with the UI that we ship. So the UI is entirely dependent on the workload, whatever kind of workload that you're deploying. So when I say workload, it is the flavor of Kafka. So either open source or Confluent or Netpanda, WebStream, or whatever other workload that we support. So the UI is entirely dependent on that. But there we ensure that it has the highest security mechanism possible there. Yeah. I hope that answers.
For questions?
I'm curious more on how your billing manager works.
Right. So there's multiple. There's two ways of doing chargeback here or billing. We do usage based or cost based. So usage based is based on the actual usage, that is based on various parameters that you can define upfront. So this, since a lot of this is customizable for the organization that you want to deploy in. Some organizations might want to do a chargeback based on the number of partitions, or based on just throughput, based on ingress, egress, or just based on storage. So these are parameters that you can configure for how much do you want to bill per partition, per MB throughput, per MB storage. That is usage based billing. And for cost based billing, we provide open cost, which is going to actually query the cloud provider and try to get the actual cost of running Kafka on the cloud. Because a lot of this, even though it is private cloud, is running on the customer's cloud environment. So that's where cost-based billing works really well. But the actual calculation is just again done in the durable execution engine, which regularly just queries for these metrics, computes it, and ensures that it stores that